Well, we were studying logistic regression. Okay. And in logistic regression, I told that the relationship between dependent and independent variable is based upon logit. Okay. That means you are having log of odds. Fine. So the issue with the linear regression, I already told, it's unable to classify, and the prediction done by the linear is continuous in nature, and then here in case of classification we can't deal with the continuous data. Okay, so for that we require a different classifier, so logistic regression came into the picture. Okay, and we do have a sigmoid here. Yesterday I told that this is sigmoid. Okay, and its value is between 0 to 1. Fine. And there is a threshold here, that is zero point 0.5. Okay. So it's a non-linear function, sigmoid. And for it, the equation is given as 1 upon 1 plus e ki power minus x. Okay. This is how the relationship has been given between dependent and independent variable, y equal to 1 upon e ki power minus x. Okay, fine. So I think till here I've already taught you. Okay, and yes, I also told you that because if you are writing it like this, p is the probability. Like, okay, we can write like this: p equal to 1 upon 1 plus e ki power minus y. That is 1 upon 1 plus e ki power minus beta naught plus beta 1 x. Okay, and then we should be having here three cases. I told you that if beta naught plus beta 1 x is equal to 0, beta 1 plus beta naught plus beta 1 x greater than 0, or beta naught plus beta 1 x is okay, greater than 0 and less than 0. Okay, so we are having the three cases here. Okay, fine. So if it is equal to 0, then we are having the probability value as zero point 0.5. If it is greater than 0, then we are having a probability greater than zero point 0.5 and the answer will be 1. Here also we say that the answer is 1. And if it is less than 0, then the probability value is less than zero point 0.5 and here the answer is 0. Okay, that means if you are doing binary classification, this will be the result. So you can put the value here, beta naught plus beta 1 values, you can put it here and you will get these respective values. Okay, fine. Then I need to explain you odds and the odds ratio. That's what I am telling. Yesterday class also, I think I did mention that odds. Odds. What do you mean by odds? See, odds. It is a ratio of probability of success to failure. For example, p is the probability of success and 1 minus p is the probability of failure. So the ratio of p upon 1 minus p is called as odds. This is called as odds. Okay, fine. And the next, odds ratio. What is odds ratio then? Odds ratio is, see, it is the ratio of the odds in presence of B and odds of A in the absence of B, and vice versa. And vice versa. Actually, now you can write like this: if success is equal to P, probability of success is P, probability of failure is 1 minus P, then odds for success is given as P upon 1 minus P. Odds for failure can be given as 1 minus P upon P. Okay, this is how we can give. And for binary classification, for binary classes, we can give odds ratio as P1 upon 1 minus P1, P0 upon 1 minus P0. That means probability of getting 1, P1 is a probability of getting 1, P0 is a probability of getting 0. Okay, 1 minus P1 is probability of getting not getting 1. 1 minus P1 is probability not getting 1. 1 minus P0 is a probability of not getting 0. Okay, so I took this under consideration. This is success, this is failure. Okay, so this is for your 1 probability of getting 1. Okay, fine. And then this is your probability of getting 0 and not getting 0. These two ratios are called as the ratio of them are called as odds ratio. Okay, fine, got it. Now now very much important, this odds ratio. Okay, because we have to consider it, okay, in our algorithm. Fine, now let me share my entire screen. Okay, let me share my entire screen. And let me talk about the logit function. Okay, so logit function logit function is given as log of p upon 1 minus p, because it is called as log of odds. Okay, logit function is called as log of odds. Odds you very well know. Odds means ratio of success to the failure. So this is called as odds, success to failure. But okay, and I'm taking odds ratio. Odds ratio is if you are having binary classification, this is 1, this is 0. So what is the odds for 1 and what is the odds for 0? These you have to calculate individually and then you have to take the ratio of them. It is called as odds ratio. Logit function is log of odds. Okay, so that's what I took. This is odds, so I took the log of it, log of odds. Okay, got it. So let me write it again. Uh, Here, let us suppose y equal to log of p upon 1 minus p. Let us suppose this is base log to the base e. Okay, so I can take e to the power y equal to p upon 1 minus p. Okay, what is y? What is y? Y is okay. Let it as it is right now. Nothing to do. E की power y into 1 minus p equal to p. Then this is e की power y minus e की power y into p equal to p. Then take this thing on the right hand side. So e की power y equal to p plus e की power y into p. Then e की power y equal to take p common 1 plus e की power y. Then p will be equal to e की power y upon 1 plus e की power y, and then p is equal to take e की power y in denominator, so it will be 1 upon e की power y plus e की power y upon e की power y. So this will be 1 upon 1 plus 1 upon e की power y. It can be rewritten as p equal to 1 upon 1 plus e की power minus y. Okay, and then I can write it as e की power minus beta naught plus beta 1x. This is your probability, very much important. Your logistic regression function gives probability only. It gives you probability scores. Remember? Okay, so here we are taking probability scores only. Okay, so this is a probability score. Later on, you can check if probability score is less than zero point 0.5, output is 0. If probability is greater than zero point 0.5, output is 1. And if probability is also equal to zero point 0.5, equal to zero point 0.5, then also output is 1. This is what you can do. But your outcome is a probability, remember. Okay, so there are certain technical terms they are telling to you. They are saying that, boss, you are doing classification now. That's what you are doing, and we are expecting outputs in terms of probability. Okay, you will be getting probability scores, not 0 or 1. No, you will be getting the probability scores. Okay, let us suppose we are having class A, class B, or let us suppose we are having 1 or 0. Okay, so your model can give answer as 1, your model can give answer as the 0. There's a possibility, na? Model can give answer as 1, model can give answer as 0. Okay, so this is an unexpected. There is an unexpectation, no? So probability is unexpected, no? Okay, that's the reason. That's the reason we told that. Okay, let's consider odds. Odds means success upon failure. This is called as odds. If P is the probability of success, then 1 minus P is the failure. So this is called as odds. Then you have been told for odds ratio. Okay, odds ratio. So I need to calculate odds for 1. I need to calculate odds for 0. That's what I need to calculate. Let us suppose the odds for 1 is P1 upon 1 minus P1. Okay, here is I'm getting the P1. That means 1. And here I'm not getting 1. Not getting 1. Okay, and P0 upon 1 minus P0. Here I am getting 0, and here I am not getting 0. Not getting 0. So let's take the ratio of these two. It's called as odds ratio. Okay, then I told that I am going to use logit function. Okay, we use logit function. Logit. And logit function means log of odds. So I do have an odds. P upon 1 minus P, and that's what I solved. Here I solved that thing only, log of odds. And the value P, which I'm going to get from here, that is a probability. And this is what your model gives. Model always gives probability. Then later on, it's your duty, okay, to perform this thing. A probability is greater than 0.51, less than 0.50. This is you have to do. Logistic regression model always gives a probability according to this formula. Understand? Okay, got it. So, yes, this is what the probability finally P equal to 1 upon 1 plus e k power minus beta naught plus beta 1x. All right, fine. Now, see, as we are doing classification, okay, and every classification algorithm, classify means I need to separate. This is A, this is B. I need to separate. That is how you called as a classification, na? That means separating. So in our data set we are having either 0, either 1, either A, either B, or we are having multi classes. I need to separate them. So when you study classification, you do study decision boundary. Don't forget this thing. Decision boundary. In classification algorithms we have to define decision boundary, because I need to take the decision now that till here the data points belongs to class A, till here data points belongs to class B, and this is the boundary. This is how I am classifying. So this is for A and this is for B. Okay, fine. So here we are defining the decision boundary. A and B separate. So separating classes. and the classes can be separated on the basis of decision boundary. Okay, a decision boundary can be linear in nature, it can be non-linear in nature. Okay, it can be linear, it can be non-linear. Decision boundary can be anything. Okay, right now I have shown you linear decision boundary, but it is not mandatory that the classes are linearly separable. This is a case of linearly separable data. Okay, that means I can separate it with a single line, but it is not mandatory. Okay, fine. It may happen that you have to separate classes with any polynomial. Let us suppose this is class A, this is class B, and this is how the distribution of data. So this is linearly inseparable. Okay, that means with the help of polynomial, you have to separate it. So it's inseparable. All right. Now the case is, sir, in logistic regression, how you're talking about decision boundary. What we have learned so far is, sir, logistic regression is sigmoid. It is non-linear, sir. You are talking about threshold in logistic regression, which you defined it as zero point 0.5. You told that everything here depends upon probability. You took log of odds. Odds, you are saying that it is p upon 1 minus p. That means it is a probability. So you are totally talking about probability. Okay, that means probability of an outcome. So do we have to make any decision boundary like this? See, decision boundary is a general concept for classification. It's a general concept for classification. Whether you study logistic, whether you study SVM, whether you study any other algorithm like decision tree, random forest, you will be getting the decision boundary because I need to separate the classes. So for separation, you require something. Okay, so here I am talking about the probability of outcome. I am talking about probability of outcome. An outcome can be like 1, outcome can be like 0. Whatever be the probability of outcome is, I am going to consider and then I am to apply the threshold. Finally, I will say that whether it belongs to class A, whether it belongs to class B. This is what I can do. Okay, so probability. We are not specially creating a line, we are not specially creating like as I did non-linear thing. That's not we are doing. We do have a sigmoid function, and this is your, okay, this is 0, this is 1, this is your zero point 0.5, and this is your x, this is your y. whatever be whatever be the values of your x, whatever be the values of your x, the y will either be 0, either the y will be 1, it will be 1, either the y will be 0, either it will be 1. Okay, these two. So this is a probabilistic curve. It doesn't mean that, sir, you're talking decision boundary. So, sir, are the points present here? Are the points present here? See, by this probabilistic curve, I am defining relationship between the data points, dependent and independent. I'm defining a relationship between the data points. That's what I'm doing. See, you are still learning logistic regression as linear model. Logistic regression comes under linear model. That is why if you see in probability also I have written 1 upon 1 plus e की power minus beta naught plus beta 1 x. This is your y. beta naught plus beta 1x. So we are not ignoring it. The only thing is, we are calculating the probability now. That's what we are doing. Rather than we are taking the regression continuous points, we are taking the probability, and according to probability we are defining. So don't think that, sir, this is a decision, like this is a decision boundary, here class A is present, here class B is present. No, this is your 0 class and this is your 1 class, and this is the threshold. Above this, okay, so you can imagine right now that this threshold is a decision boundary. That's what you can say. That's what you can say. This threshold is a boundary, but not specifically. I'm writing it as per for your understanding. I just mentioned, but not specifically. I do. It's just a threshold value of probability. Okay, class A and the class B. This is how we can write. Okay, fine. Did you understood odds, log of odds, probability? Did you understood or not? You know now odds why we are calculating, because see, you are dealing with a classifier. You can get any of the outcome. So you have to apply probability. You are checking that, okay, and getting one is a success, not getting one is a failure. Getting zero is a success for zero, not getting zero is a failure for zero. Okay, so and interpret accordingly. Okay, we are having two classes. Either I'm getting one, so it's a success for one. Not getting one is a failure for one. Okay, and same for the zero. And I took the log of it, I gave the probability, okay, and I've drawn the curve. I talk about the decision boundary also. So here the threshold can be just like a boundary, but not specifically we are mentioning here that, okay, as we do now with x and y, like, okay, just zero are the outcomes that are all on the x axis. Okay, and y are the outcomes, the one value, they are on the y axis on the top. That's it. You can see here on the top. That's it. So why all the zeros for any value of x? Okay, 0 here and 1 is here. That's it. Nothing else. Okay, fine. All right, all right, all right. I have many more things, but they are very much important. I need to talk about the cost function of logistic regression, though we are not having more people today. Okay, let me stop it.